Hey everyone, we're going to look at this motor efficiency exercise. It's on a Google form. So the first few fields there are fairly straightforward. It's just your name and ID. What we've got to do is we've got to put some data in here. So the data, 1, 2, 3, 4, 5, 6 data, okay? So the current. So we're going to be looking at the power in and the power out of the motor. So the power in of the motor is we can do with electrical calculations. So we can use current, voltage and power factor, these three here. So that one there will give us our input power electrically measured, and that will give us power in watts. And then our output power we can measure mechanically, okay? So we can measure mechanically using a formula 2 pi nt over 6d. So to do that we need the RPM and the load on the shaft. So we need the shaft speed and the torque on it. So we can work out the torque by doing some mechanical calculations, putting a scale on it and measuring the force and the torque, and that would give us our power. So we're going to be working out our power mechanically on our output and our power electrically on our input. Once we have our two powers, which down here, we'll have our input power, electrical, have our output power, mechanical. We can work out the efficiency. Output power over input power times 100 will give us a percentage, okay? And we can work out how efficient our motor is, and that will give us an idea of the losses. Excellent. So let's look at the first 6 questions. You just got to fill your data in. Where do you get your data from? You're going to get your data from your unique ID. Come down here, find your ID, and just load that data straight in. Amps, volts, power factor, RPM, arm length, and kilograms. That lines straight up with here. Amps, volt, power factor, RPM, arm length, kilogram. Easy. Okay, calculations. Let's look at the calculations. Get rid of that for the moment. We don't need that anymore. I'm going to start here. Output power. Output power, if we're measuring it mechanically, P equals 2 times pi times n times t, all divided by 60. Okay, n is RPM. That's our revolutions per minute. RPM, right there. T is the torque. So RPM we know. Got that up here listed. T, torque. We have to calculate torque. We can calculate torque here. Torque is force times, because it's Newton meters, is the length of the arm. So I'm just going to put a little picture here. Delete some of this stuff. So, reads better. Sorry. If I have a shaft, if I want to measure torque, I can put an arm on it, and it's going to rotate like this, okay? And I can measure the force on this, and I also need to know the length between here and here. Those two factors will tell me the torque on the shaft. I could have a longer arm, my force would be less. Shorter arm, my force would be more. Okay, so in our exercise we've measured with a scale right here. We've measured kilograms just on a spring scale, and the arm pulls down on it, so we need to know the length of the arm and the kilograms. Right, let's get rid of that. So going back to this torque, so calculate torque, Newton meters. So torque will be the force and the radius. So this one here is your arm length. Arm length. Okay, and that is in the data right here. Sorry, let's go to arm length. Okay, so you got that number, right? So the arm length goes in there. F, force. We don't know force yet, but we know the weight. Mass. Mass times gravity is force. Force equals mass times gravity. What's gravity equal? Gravity equals 9.81. Isn't that right? 9.81. Okay, there's our gravity. Mass. Where's our mass? We know our mass. Our mass is kg. There's our mass. So this first bit here, although we work backwards, the first bit here we're going to get our mass. We're going to change it to a force. We're going to get our kilograms. We're going to times it by gravity, 9.81. That's going to give us our force. We're going to put our force in there, and we're going to times it by R. R is our arm length. So it's going to be arm length times kilograms times gravity. That will give us our torque. Then we can put our torque in here, times the RPM times 2 pi. 2 pi is fixed, and we divide it by 60 because it's RPM. 60 minutes an hour, 60 seconds in a minute. So we divide it by 60. That will give us our output power. And you can put your answer in there. Right, input power is a lot more straightforward. It's our voltage, which we measured, and we got off our data, times our current. There's our power, V times I, times 3, for 3 phase, because we're using our phase and our phase voltage and our phase current. So we times it by 3, that'll be our total power. And then the power factor, times by the power factor, okay? That will give us our input power. All that data's up there. VI power factor times it by 3. Easy. Then do your efficiency. Output power over input power times 100 to turn it to a percentage. That's the calculations you've got to do from your set of data. Everyone's got a unique set of data. Load it in here. Do your calculations. Watch the video and it should all make sense. I'm going to finish that there. Command, Option,